I'm a big movie fan and I was always wondering how people look at movies, and with my research work I can get an answer to this question. My name is Kuno Kurzhals. I work at the Visualization Research Center as a PhD student. The main focus of my work is on visualization of video data in combination with eye tracking. With eye tracking we can record where people look at, for example at the monitor when they watch a video, and usually we conduct user studies where many people participate, and then we want to compare this data. The challenge here is that we have a lot of data. So for example, with an eye tracker with 60 Hz, we have 60 data points per second, and we have many participants. And additionally, we have the video content. And the main challenge is to bring all this data together to get information out of the recordings. My research focus is on developing new visual analysis tools that help to understand this huge amount of data. In this visualization here, this is called a space-time cube. We have the data points from all participants and how they distributed over time in a three-dimensional representation. So for the first time step, we can see here a memory game and how 25 participants looked at this video frame. And in the space-time cube visualization, we have the X and Y dimension of the video extended by the third dimension, the time, and we can show all the data points in a static overview. When we play back the video, we can see that all participants focused on this region at the same time. After both cards are visible, the participants distribute their attention between those two cards to remember the cards. With our visualization, you can see directly in an overview where something interesting might have happened. To see individual differences between the participants, we have another visualization that is called the gaze stripes. And there we take all the gaze points from the participants and cut out small image regions from the places where they looked at. And we put all these images in a sequence for each participant. So we have for all 25 participants our data represented as small images. And with this representation we can easily identify the order in which participants looked at the different cards. So it's quite easy to see without playing back the video where interesting behavior occurred, where some participants maybe looked at an unexpected region and when they switched attention between different objects. We've noticed that eye tracking has become more and more popular over the last years in scientific research, and we think this trend will go on in the next years. And therefore we need new analysis software and approaches that help us to understand this huge amount of data.